Beijing Dahang Transition Technology Company Limited, or Cosmoleap for short, is a hard technology company focusing on the research and development and operation of medium and large reusable launch vehicles. This company is very young. It only started operating in March 2024. Cosmoleap adheres to an engineering culture that is committed to building low-cost, highly reliable, reusable launch vehicles and supporting satellite internet engineering construction, according to their website. Cosmoleap has been positioned to build large-diameter liquid rockets since its founding. The development path is clear, the team lineup is excellent, the tower recovery scheme is unique and efficient, and they have rich engineering experience that has been accumulated to pave the way for this development. What China needs, according to a shareholder, is not China's Musk nor China's SpaceX, but the strength of the entire industrial chain. They believe that the focus on liquid recyclable rockets, with no historical baggage, will give them a latecomer advantage. Cosmoleap is designing and building a reusable launch vehicle. This reduces the launch cost of each vehicle, and only refurbishment and maintenance is needed between launches after the vehicle has been built. Another major advantage of a reusable launch vehicle is it supports a high launch cadence. This is not guaranteed, it depends on where the vehicle lands. For vehicles returning to or near the launch pad, they can be quickly turned around and fly again. Vehicles caught at sea will need to return to land first, which can take weeks at a time. The ideal situation is for the launch tower to catch the vehicle directly. This is what SpaceX is doing for Starship, with one successful catch already demonstrated. Cosmoleap aims to do the same thing and have already constructed a recovery tower, as they call it. Unlike Starship though, the Cosmoleap is much smaller, with a diameter of only 4 meters compared to Starship's 9 meters. In reusable mode, it can lift 6 tons to orbit and 10 tons in expendable mode. A more ambitious launch vehicle with 100 tons to orbit is planned for around 2030. From their website, they explain in more detail the technical issues that need to be solved to recover a launch vehicle using a catch tower. Precision return flight and safe landing control technology. After the first and second stage separate, the first stage is programmed to return back to the launch pad. Using thrust vector control systems, grid rudder, surface and other control mechanisms, the first stage can maneuver from low Earth orbit back through the atmosphere to position itself to be caught by the recovery tower. Cosmoleap understands that to safely and reliably catch a returning launch vehicle, the engines will need to have multiple restart capability and variable thrust control. Another big problem that needs to be addressed is that the return vehicle will have used up 90% of the propellant, resulting in reduced tank pressures. This makes restarting the engines more difficult, and that's before considering fuel slosh or fuel hammer problems caused by the first stage being in low gravity and spinning around during a boost back maneuver. The vehicle must come to nearly zero velocity at the launch tower, which requires complicated flight control software to make adjustments as the vehicle approaches the launch tower. Cosmoleap is also thinking hard about building a highly reliable landing buffer mechanism to minimize the force of impact at the moment of landing. It must also be able to scrub any residual speed to ensure a stable landing. To ensure high cadence, Cosmoleap is also researching how to rapidly inspect and maintain a return launch vehicle so that it can be quickly returned to flight. Traditional methods of inspection usually require disassembling the vehicle. For high cadence operations, Cosmoleap must find non-invasive methods for inspection and detection of defects. Cosmoleap is developing a new generation one-stage reusable rocket. It's designed to fly 24 times per year and can fly 150 tons per year into orbit. Tower recovery is possible on both land and island. I'm not sure what is meant by island. Does that mean a landing zone, or an island, or a tower? In reusable mode, the vehicle can launch not less than 6.28 tons to orbit. The first flight is expected in a few years, probably 2026. Each vehicle is designed to be reused 15 times. Components for the vehicle will be attained easily through what they call, and I'm quoting here, rapid matching based on supply chain prosperity, unquote, whatever that means. Now on to the recovery tower. A recovery tower will be used to catch a returning launch vehicle. This eliminates the need for landing legs, reducing the vehicle weight and improving mass to orbit. It can also prolong the life of the engines, since there is no reflection of flames or ablation of the engine jets when landing on the ground. The recovery tower is broken down into a number of different technical areas that need to be addressed. First is the design and manufacture of the tower structure and recovery arm structure. Second, a high dynamic fast response hydraulic system is needed to control the catch arms, or chopsticks as SpaceX calls them. Third is what they refer to as a automatic motion control system. And finally, a high precision approach identification and positioning system. Okay, let's move on to the milestones now. Let's go over the key milestones for Cosmo Leap so far. In November 2024, the first tower recovery test started. Cosmo Leap is the first Chinese company to develop a chopstick holder, that is a tower for recycling and reusing liquid rockets. Cosmo Leap has begun testing of the tower, which required an extreme focus on innovation and technology. They have assembled groups of high-level research and development teams, led by academics and consultants, in the construction of this recovery tower. Key technical problems are the chopstick clamp and the flight control computer and the recovery tower controller. A number of tests will be required to ensure that both computers, vehicle and tower, can communicate with each other during recovery and that the tower clamps can successfully latch onto and catch the vehicle. A successful lifting test was carried out this November. Now on to upcoming events. More testing of the recovery tower is expected in 2025. The first flight of their reusable vehicle is not scheduled for a number of years yet. A slide translated from Chinese has the text "First Flight 2026" for their smaller launch vehicle capable of carrying 6 tons to orbit. Their larger 100-ton vehicle, which looks similar to Starship, has the text "First Flight 2030. We'll keep an eye on this ambitious Chinese space startup and see if they can replicate what SpaceX has managed by catching a returning launch vehicle. Okay, that's it for this video. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.